Hello, Algebra 2 students. We are going to start 8-1 here. Multiplying and dividing rational expressions. We're going to be able to simplify using multiplication and division. And we're just going to focus on the simple rational expressions, and complex we'll do in class. So what we're going to do, hold on, I want to see if I can get full screen here. Okay. So I got this lesson off of the internet, so it's a lot of words, but I think it'll help you. So an algebraic fraction is sometimes called a rational expression, and it's simply a fraction where the numerator and denominator are polynomials. So here are some examples down here. You can write those down if you want to. You don't have to, but there are some examples. But this is what we're going to be dealing with, and we're going to be simplifying these in this chapter. So one thing to be mindful of when working with fractions is the denominator cannot equal 0. And we know that because the universe might explode. So for example, if we have 5 over x, x can be any real number except for 0 for that one. And hold on here, let's see. I want my pen. There it is. Okay. So x cannot equal 0. And for this one, if you set that equal to 0, x cannot equal 5. And in this algebraic fraction, we have x squared minus 9. That cannot equal 0 when we solve for x, and we were to factor that. When we set those equal to 0, x cannot be -3 or 3. And we've kind of had an introduction to this before. So just keep that in mind. There might be some restrictions. So just like simple fractions, algebraic fractions can be added, subtracted, multiplied, or divided. All the operations work the same as you learned in earlier grades. However, they do prove to be more challenging. We will start with simplifying or reducing fractions. Remember, you always want the fractions given in simplest form, so you are looking to see if the numerator and denominator have common factors to reduce with. So we're always simplifying. So let's look at this first example. First of all, you need to look to see, is there anything you can factor out on top in your numerator? No. What about on the bottom? No. So we have 20 over 35. They're both divisible by 5. So we can simplify this down to, this would be 4 over 7. So you have 4/7 here. Now remember, x to the 4th over x to the 3rd, when we're dividing the same base, what do we do with the exponents? We subtract them. So this would end up being x to the 1st, and that'd be a positive one, so it comes up on top. And then we have right here, 3 minus 1 is y squared, and again that comes out on top. So we could clean this up. It'd be 4/7 xy squared. Alright, so that we just simplified a rational expression, and that's what we're going to be doing throughout this whole video. Alright, so for this one here, same thing, we have some factors. It's already factored for us, and we can cancel out factors. Alright, so if you notice they have the same factors here, we can cancel out the 3x minus 5. Now can we factor these down any farther? 2x minus 7 and x plus 14. Can't factor anything out, so our final answer is going to be 2x minus 7 over x plus 14. And it's just like when you factor things out, like for example, if we had 8 over, what do I want to use here? Let's see, 8 over, we could use 20, for example. They both have 4 in common. So if we were to factor out a 4, this would be 4 times 2, and this would be 4 times 5. They both have a 4 in common. Both have 4s as factors, so we can cancel those out. Same thing here. These both had 3x minus 5 in common, and so we could cancel those out. Now, do we do it this way? No, we just simplify it. So But keep that in mind. We're canceling out factors, getting rid of factors, slimming down here. So let's look at this next example here. Look at the numerator. What can we factor out of the numerator? Factor out an x squared. What else? A 7. Very good. So when we factor out a 7x squared, what are we left with here? We divide by 7x squared here and 7x squared here. We're left with, it looks like an x minus 3. Very good. And this can't be factored at all, so we just have 6x squared. So now what factors do they have in common? So again, this is a factor. Factors are multiplied, so that's why we can cancel them out. So we can go ahead and cancel out the x squareds. Now we can't cancel out 6 and negative 3 because this is a factor. X minus 3 is a factor. It's together. Stays together. X minus 3 is its own term right there. So our final answer is going to be 7 times x minus 3 over 6. That would be our final answer. Let's look at the next one. So what I want to do is I want to factor this first. So x squared minus 4, we can go ahead and factor that as x plus 2 and x minus 2. Down here, how can we factor this? So we could write it as, what two values? When you multiply them, you get negative 2. When we add them together, you get negative 1. Negative 2 and positive 1. Very good. So now what factors cancel out when I simplify this? Very good, the x minus 2's. So now we're left with x plus 2 over x plus 1. And we can't cancel these out because, again, these are factors. They are their own term. They stay together. Now, looking at these two problems, what are the restrictions in the denominators? So, for example, right up here, what can x equal? X can equal 0. Very good. And we're going to look at the original when we do this. Okay, so x can't equal 0. We can't plug that in. What about here? What can x equal? If we were to set these factors equal to 0, x can equal 2, and x can equal negative 1. So make sure you put those restrictions on the original. Okay? All right, and I'm going to take a moment here. Pause for a second. All right, I'm back. Let's get this in full screen mode. Okay, so we just did this. The other thing I was just thinking of was the reason that we can cancel these out as well is because, keep in mind, we're multiplying these factors, and to undo multiplication, you can divide. So you can't undo these because you're adding here. You're adding x plus 2, and you can't get rid of an x by dividing. That just doesn't happen. All right, that in division and adding are not inverses of each other. So I kind of think of it that way as well. Okay, so let's do this next one. You're going to have to find out what the factors are. So we're going to go ahead and factor x squared plus 5x plus 6. And we're going to write down, let's see, x would be plus 2 and x plus 3, right? All right. So then we have x plus 3 on the bottom. What factors can cancel out? What do they have in common? Ta-da! So the answer when we simplify this down is x plus 2. Oh man, does that feel good to simplify that? Okay, and so here we have x plus 3. What are our restrictions? X can equal negative 3. Very good. So this is our answer. This is our restriction. Okay. What about this next one? Okay, this right here, factoring, can't use Argyle, can't use T, so let's go ahead and find some GCF here. So we have a 5, we can take out a 5, and we get x squared minus 4, right? Oh, hey, we know how to factor this. We know how to factor this, so it's 5 times x plus 2, x minus 2, using our little shortcut. And down here, we just did that one up there. It was x plus 2 x plus 3 right here, factoring. We're little factories here, we just factor all the time. So we have x plus 2 and x plus 3 here. So what can cancel out? That's my favorite part of math, canceling stuff out. Woo! All right, so the x plus 2's can cancel out. Our final answer is going to be 5 x minus 2 over x plus 3. Nothing can cancel out here, can it? Nope, the factors don't look alike. We can only cancel out like things. So in our restrictions, what do we say? Here, x can equal -2 and x can equal -3 for that. So that would be our final answer. All right, so this is kind of hard to put in the Google form, but I want to see if you've watched it or not. So I'm trying to think of something you can put in the Google form. So in the Google form, I want you to write down my pet's name. And my pet's name is Tracker with a T. Tracker. Alrighty? So that's what your answer, what you're going to put in the Google form. Alright? And he's my dog. Tracker the dog. Alright. We will, that's all I have for you. That's it. That's it for this video. So I will see you guys later. Come with lots of questions. And yeah, have a good day, good evening, good night, whenever you're watching this. We'll see you later. Adios.